Chapter 2: Energy, Energy Transfer, and General Energy Analysis. All right, everyone. Today we're going to talk about something you deal with every day, but probably never think much about: energy. Energy is like the invisible friend that's always helping you. You don't see it, but it helps you play, run, drive cars, cook food, and even keeps your room cool or warm. So let's have fun learning about energy the way we would tell a simple story. First, imagine energy is like different types of fuel for your body, cars, machines, and even for things like lights and fans. Energy comes in many forms, like when you feel heat from the sun, that's thermal energy. When your toy car moves fast, that's kinetic energy. When you lift your backpack up, you store potential energy. Electricity that powers your fan is electrical energy. There's even chemical energy in your food and nuclear energy inside the sun and power plants. When energy moves from one place to another, it does so in two main ways: heat and work. Think about it like this. When you touch a warm cup, heat is moving to your hand because it's warmer than your skin. That's heat transfer. But when you push your toy truck, you are doing work because you are applying force to move it. It's super important to remember, energy doesn't disappear or come from nowhere. It just changes form. This rule is called the first law of thermodynamics. Let's play a thought game. Imagine your room is fully closed, like a box, and you put a fridge inside with the door open. You plug it in. What happens? Does it get cooler inside your room because the fridge is open? Nope. Actually, it gets warmer. Why? Because the fridge takes electricity, works to keep its inside cool, but throws all the extra energy out into your room. So your room gets hotter. The total energy in the room increases. That's because energy can't just go away. It moves and changes form. Now, energy is made up of little parts. There's energy you can see, like moving things, called macroscopic energy. Then there's energy hiding inside the tiny moving molecules, called microscopic or internal energy. Think of macroscopic like when a car moves on the road, and microscopic like the shaking of atoms inside a hot soup. When we talk about how much energy something has, we include both the energy because it's moving or at a height, kinetic and potential, and the energy hiding inside it, internal energy. And when things don't move or change height, the only thing that changes is the internal energy, like when your hot tea cools down while sitting on the table. Now, let's talk about flow. Imagine water flowing through a pipe. This moving water brings along energy, not just because it moves, but because it has pressure and height too. The faster it moves, or the higher it is, the more energy it carries. Another fun thing about energy is how it hides inside objects. When you heat a piece of metal, the tiny atoms inside it jiggle faster. That's what we call internal energy. Sometimes the energy changes the phase, like ice melting to water, and we call that latent energy. When you eat food, the chemical energy in it helps you run and play. Even inside atoms, there's nuclear energy, which is super powerful, but only used in special places like power plants. When energy moves by heat, it always moves from hot to cold, just like how an ice cream melts in your warm hand, but your hand doesn't freeze from touching the ice. If there's no temperature difference, no heat moves. Simple, right? Then there's work, which happens when you use force and move something. Like when you pump a bicycle tire or wind up a toy, you are doing work. Even electricity is work because it moves energy using little particles called electrons. Think of it like a magic rope that pulls energy to make things work. Different types of work exist too, like when a wheel spins, that's shaft work. When you pull a spring, that's spring work. When you stretch something, you are doing work too. Even flowing fluids have something called flow work, where pressure helps push fluids along pipes. At the end of the day, energy is like a big puzzle. It can't disappear, it only changes its dress. Sometimes it's heat, sometimes movement, sometimes pressure, sometimes hidden inside atoms. Our job as engineers is to know how to count this energy, change it to forms we want, and use it wisely without wasting too much, because wasting energy also means harming our planet. So, next time you feel hot, run, or turn on a fan, remember, energy is at work, changing forms, traveling around, but always following the rule. It never disappears, it just changes homes. That's all for today. Next time, we'll dive deeper into fun ways to see energy working around us.